Hey everybody. Today we're sketching derivatives from graphs. Remember, the derivative of a function just tells you the slope of the line tangent to the original function at any given x value. For instance, let's look at this graph. It's y equals 4 minus 1/4 x squared. It's a downward opening parabola. And let's sketch the derivative. First of all, notice that at x equals 0, a tangent line to this graph is going to have a horizontal tangent. Slope 0. So at x equals 0, the derivative is 0. The graph of the derivative has to pass through the point 0, 0. For negative values of x, so on the left part of this graph, any tangent line to this graph is going to have positive slope. And in fact, the slope is going to be more positive the further to the left we go. Similarly, on the right part of this graph, for x greater than 0, we're going to have a negative slope. The derivative is going to be negative. And it's going to get more negative the further to the right we go. Here's a graph of the derivative y equals f prime of x. It has all those properties I just mentioned. Let's do a couple more examples. Let's swap over to GeoGebra and look at a more complicated function or two. Okay, so here I've graphed a function y equals f of x. I've also put down a moving point here along with a tangent line at that point. Our goal here is going to be to sketch the derivative of this function. First of all, notice that there are a couple of values here where we get a derivative of 0. We have horizontal tangent lines right here, right about negative 1.4, and here, right about positive 1.4. So let's actually plot the points on the graph of the derivative. Something like that, and something like that. That's just approximate, but close enough. Okay, what about in between? In between points C and D, for x values between there, all of the tangent lines are going to have positive slope. The slope is going to be positive but getting less up here. It's going to be positive and getting less down here. It's going to have a pretty big value right around 0. So I'm expecting the graph of the derivative to sort of have an arc like this. On the far left of the graph, the derivative is going to be negative, so I'm expecting the graph of the derivative to be down here somewhere. And on the far right of the graph, the derivative is also going to be negative. See the negative slope of the tangent line here? So I'm expecting the graph of the derivative to be down here. Let's actually see f prime. There it is. Again, it has all the qualities that I just mentioned. Let's do one more example. Don't need to save that. Okay, so our goal here is the same. We want to try and graph the derivative function f prime of x. This time I have a moving point but no actual tangent line, so that gives us the opportunity to try and imagine it. Again, I think it's easiest to start looking at for horizontal tangents. Here, right around negative 1.2 or so, we have a horizontal tangent. We expect the graph of y equals f prime of x to have a 0 there. Again, this point is just approximate. We'll draw the actual derivative in just a minute. Now, for most of this graph, I'm seeing a positive slope, a gentle positive slope. Right near 0, though, things change. Here, the derivative, the slope of the line tangent to that graph, is going to go from positive to negative, right about there. And in fact, it's going to get more and more negative as x gets closer and closer to 0. Therefore, the graph of the derivative function for this function is going to have a vertical asymptote at x equals 0. To the right of 0, for example here at x equals 0.4, the tangent line is going to have positive slope. It's going to have a very high positive slope, as a matter of fact. So on the right side of the vertical asymptote at x equals 0, we're expecting the graph of y equals f prime of x to be coming down from positive infinity. Then, as we move further to the right, the slope stays positive, but it begins to level off. As I graph y equals f prime of x, I'm expecting a horizontal asymptote as x goes to positive infinity or negative infinity, corresponding to the slope of this graph that we seem to be settling down towards as x gets bigger and bigger in either the positive or negative directions.